Okay, we are only going to deal with the double angle formulas from 7.5, so you do not need to know the half angle formulas at all. You will deal with those in pre-calc next year, but not this year, so don't worry about it. But the double angle formulas, all right, once again, u is a value of an angle, all right, so this is saying that we're taking u and we're multiplying it by 2, all right, so hypothetically, if u was 30 degrees, all right, in this scenario, if this value was 30, if we did 2 times 30, that would give us what? 60, okay? So we know that the sine of 60 degrees is equivalent to the square root of 3 over 2, correct? All right, so this side would end up being the sine of 60, which is root 3 over 2. If we did 2 times the sine of 30 times the cosine of 30, we would also get the square root of 3 over 2. Because the sine of 30 is a half, the cosine of 30 is root 3 over 2. The 2 and the 1/2 would cancel out, just leaving you with root 3 over 2. Okay, so that's a quick verification of this double angle formula for sine. And that would continue out all the way through for the double angle formulas for cosine and tangent. So the sine of 2u is equivalent to 2 times the sine of u times the cosine of u. All right. Cosine, we have 3 different options. All right. The cosine of 2 times an angle is equivalent to either the cosine squared minus the sine squared. All right. Or 2 times the cosine squared minus 1. All right. We can obtain that utilizing the Pythagoreans. So if you replaced the sine squared up here with 1 minus cosine squared, that's how we can get from here to here. All right. And then if we did the opposite and replaced this with 1 minus sine squared, using the Pythagorean, that would take us to this one. All right. So this particular value, or this particular identity, only involves cosine, which will be helpful for some things that we do later on. This particular one only involves sine. So sometimes we'll want to use the one that only has cosine. Sometimes we'll want to use the one that only involves sine. Other times it won't matter. All right, so you can choose any of the 3. All right, and you'll see that between today and tomorrow. There is only one formula for the double angle for tangent. 2 tangent u over 1 minus tangent squared. All right, so that's it. All right, any questions on the structure of those? So that's something you'll have to be able to utilize. So here's the problems. All right, this is actually, I think, the second example on your packet. All right, so find that. It's the first one? Okay, cool. Anyway, we are given in this problem a ratio. All right. So when we're given a ratio, generally speaking, what do we end up doing? Making a triangle. All right. Now, we're told the cosine is 5 over 13, and then we are also told that theta is between 3 pi over 2 and 2 pi. All right. So between 3 pi over 2 and 2 pi makes it in quadrant 4. All right. So we're going to go ahead and draw a triangle in quadrant 4. So we put a point in quadrant 4. And just like we've done in the past, we will always draw a line to the origin and a line to the x-axis. And that creates our right triangle. We are told that the cosine of theta is equal to 5 over 13. All right, in reference to theta, which would be here, 5 is the adjacent side, so we label this with 5, and the hypotenuse is 13. Okay. Using our knowledge of triples, we have 5, then what? 12 and 13. Do I just call that 12, though? No, since it is in quadrant 4, that y-coordinate will be negative. All right? Make sense? All right. Now, with that in mind, All right, we need to find the sine of 2 theta, the cosine of 2 theta, and the tangent of 2 theta. So we're going to use those double angle formulas. We're going to need to know the sine, the cosine, and the tangents. All right, we need to know all three of those. So we already know what the cosine is. But now that we established this, based off of that triangle, opposite over hypotenuse would be negative 12 over 13. So that's what the sine is. And the tangent is negative 12 over 5, the opposite over the adjacent. Okay. Any questions on any of that? All right. So draw the right triangle, find the ratios. And now it's just a matter of plugging and chugging. All right, really. Some of this will get a little bit more complicated depending on the problem, but essentially all you have to do is plug those values into your formula. So with the sine of 2 theta, that would be equal to, and I'll write this one out formally just so we see it. It's equivalent to 2 times the sine of theta times the cosine of theta, right? Instead of u, now we're using theta. All right. Well, what's the sine of theta? Negative 12 over 13. And what's the cosine of theta? 5 over 13. Notice that when we plug those values in, the sine and the cosines drop out. Okay? We know what the sine of the angle is. We know what the cosine of the angle is. So life is good. We just plug that stuff in. Okay? And then you can type that into your calculator and get your answer. So I want the answers for these as fractions. So that's going to give you negative 120 over 169. Okay. All right. For the cosine of 2 theta, if you just had to figure that one out, you actually wouldn't have even needed the triangle, because for the cosine, you have a double angle formula that just uses cosine, correct? Okay, so you could have actually found that out without drawing the triangle. But you have a choice of any of those three, all right, and it doesn't matter which one you choose, all right? So does anyone have a preference? One with just cosine, so what is that one? All right. So if we use that one, and again, it would be the same if we did either of the other two, it doesn't matter. All right, in this case, we'd have 2 times, what's the cosine of theta? 5 over 13, and we're going to square that and then subtract 1. So if we type that in just like it looks, make sure the 5 over 13 is in parentheses, get it as a fraction, we get negative 119 over 169. And again, if you chose either of the other two, it wouldn't matter. All right, it would work. You get the same value. All right. Must be close to a 45-degree angle, right? I guess. Actually, it's not. I have to look at that in greater detail. Well, actually, it could be because it is a double. So there's the possibility. This is theta, not 2 theta. So doubling that could put it closer to a 45-degree angle, which it definitely would. Okay. Yeah. All right. Now the tangent of 2 theta. All right, we don't have a choice. We only have one option, which is what? Right. So what does it say though? There you go. Okay. So in this case, we'd have 2 times negative 12 over 5 over 1 minus negative 5 squared. And again, when we plug in those ratios, the tangents go away, okay? Just like they did in the previous one with the cosine. All right, so when you are plugging in what the tangent of theta is, here, make sure that that drops out, okay? So in your numerator, when you multiply that out, you should get negative 24 over 5. And in your denominator, if you type that in exactly like it looks, the negative 12 over 5 squared will become positive. Keep that in mind. All right. So you would actually square this first, and then do the subtraction from 1. But if you type it in just like it looks, you should be okay. That's going to give you 119 over 25, negative 119 over 25. And then you can type that in, negative 24 over 5 in a set of parentheses divided by negative 119 over 25. And that should give you 120 over 119.